In this lesson, we will learn how the JS engine handles async codes. Take a look at this example. We got a setTimeout function and assigned it to a variable, timer. Inside the callback of setTimeout, we console log 1. Outside setTimeout, we console log the timer variable. At the end, we console log 2. So what kind of result will we get? Let's do an analysis. setTimeout itself is synchronous. So when we run the program, it will immediately return the timer ID. The callback defined in it is async. The JS engine will skip it and execute the second and third console log statements. So on the console table, we will get the timer ID first. Then we will get 2, which comes from the last console log statement on line 9. At this moment, all synchronous codes have been executed. The JS engine will go back to execute the skipped callback function. As a result, we will get 1. So the final result should be timer ID, 2, and 1. We can see our prediction is correct. The question is, since the callback will be skipped first, how does the JS engine make sure that skipped codes won't be forgotten? Javascript will not leave the skipped callback unattended. It will add the skipped callback into a queue. We call this queue the task queue. After all synchronous codes from the global scope have been executed, the JS engine will go to the task queue and clear it. The queue follows the first in, first out principle. The first task in the queue will be executed first. We make a copy of the setTimeout function and place the copy behind it. The callback of the second setTimeout will be added into the task queue as the second element. As a result, it will be executed behind the callback from the first setTimeout. The result we got should be 1, 3. We can see the result is 1, 3. Pay attention here. In both the setTimeout functions, we set the delay to 0. If we give the first setTimeout function a longer delay, then the JS engine will execute the second setTimeout function first. The final result will become 3, 1. Next, we switch the second setTimeout function into a promise. We directly create a fulfilled promise using promise.resolve. We set the success value to 3 and use the then method to output it. Promise.resolve is synchronous, but its then method is async. According to what we just learned, the then method should be added into the task queue as the second element. So the result we got should be 1 and 3. We can see the actual result is 3, 1, not 1, 3. This is because there is a fundamental difference between the then method and the callback of setTimeout. The then, catch, and finally method are all microtasks. The callback in setTimeout, however, is a macro task. Microtasks will be added into the microtask queue, which has a higher priority than the macro task queue. As a result, microtasks will be executed before macro ones. This is why we got 3, 1 rather than 1, 3. The then method will be executed before the callback of setTimeout.